Okay. Thank you. My name is Yegnanew. I have a very difficult name to pronounce, Yegnanew Shiferaw. I am an associate professor at the University of Johannesburg, Department of Statistics. And my presentation is about unraveling the spatial dynamics of unemployment rates in district municipalities in South Africa. And there has been a lot said about unemployment and data disaggregation, local data. So this is just an overview of the my presentation. I will say a little bit about overview of unemployment, the data source used in the study, and methodology, results, and finally I'll say a little bit about conclusion and policy implications. So as you know, unemployment has significant social and economic consequences impacting quality of life. And low unemployment indicates a strong economy, while high unemployment suggests weakness and several social issues and instabilities. And the UN Sustainable Development Goals, there are several goals which are directly or indirectly related to employment and unemployment, particularly this one, the Sustainable Development Goal, just suggests promotes inclusive growth, full employment, and decent work for all. So estimating disaggregated, I will talk a little bit about disaggregated later. Disaggregated unemployment rates aids in understanding regional dynamics and formulating policies. Again, this is why modern states require precise data to monitor and make decisions to mitigate these issues. Studies they've been doing well in terms of when it comes to this employment and unemployment reporting on quarterly basis. It's not easy to do quarterly surveys or surveys on every quarter and report the unemployment, just general labor force statistics. So in my opinion, they've been doing quite well, so to congratulate them. However, studies say when we see the quarterly labor force survey, it's so designed to provide estimates at the national and provincial level. That's the aim of the survey. When we go down, let's say at the district municipality level, local municipality levels, or maybe when we consider, let's say, various demographic groups, like different age groups, different genders, they do not report at that level. So there is an increasing need for more detailed kind of official statistics at a more specific level or domain level. So what is domain? When we say domain in small area estimation, we are referring a specific subpopulation or geographic area for which separate statistical estimates are needed. For example, we may consider geographic areas like districts, demographic groups like genders, age, income level, disability status, marital status, race. This can be considered as a different domains. Here in this study, I tried to map unemployment at the 52 district municipalities in South Africa and further disintegrated or disaggregated by age groups. I just considered 4 different age groups: 15 to 24, 25 to 34, 35 to 49, and above 50, and conventional sex groups like males and females. So when we consider those 4 age groups, we have 52 districts, so we'll have 208 domains in general. That's how the domain is defined in this small area estimation in official statistics concept. And when we consider those males and females, by 52 district municipalities, crossed by 52 district municipalities, will have 104 domains. So we will just try to provide estimates for the domains, and in both cases for age groups and for both sexes. To achieve this, I use a spatiotemporal small area estimation technique. And this is a technique which integrates data from different dimensions or different sources. I'll talk a little bit about that. But before that, small area estimation might be new for some of you. What is small area estimation? It is a statistical science which is designed to link data from survey with other bigger administrative sources like census, and for example, in South Africa, we have also community survey, which is the one, in my opinion, which is ignored because we do not often talk about the community survey. But Study-C has been doing that in 2007, in 2015, like in between censuses. They do collect data from 3.3 million South Africans, so it's a huge data set that can be utilized. So these are the kind of things that we can use. So this approach is useful when direct survey data is limited or unavailable. This small area estimation is not new in those developed countries. In the US, they have been using this like since 70s. One of the models that I have used, in fact, there was a lot of extension after that, was developed by two experts, Fay and Heriot, in 1979. They developed this model to estimate income at the counties of the United States. World Bank has been using small area estimation for poverty mapping, especially in Asian countries. That's common, in Philippines, Malaysia, Bangladesh, but in Africa, it's not common because of the issue of data availability, issue of data problems. So as I said, the small area, spatio-temporal small area estimation in this study incorporates various data sources. I'll say a little bit more later. These are the research questions. Are there disparities in unemployment rates between men and women at the district municipality levels in South Africa? What are the differences in unemployment rate among the different age groups? And are there any disparities in unemployment rate between metropolitan and non-metropolitan district municipalities? And the main objectives are also extracted from the research questions. So this study, these are the data sources that I have used, the quarterly labor force survey data. I just consider the 9 quarters in the study from 2022 quarter 1 up to 2024 quarter 1. As I said a little bit earlier, the quarterly labor force survey exhibited high sampling variability when we consider it at the lower administrative level, because it is designed to produce or to provide precise estimators at the national and provincial level. So if we force that data to use at the lower administrative level, it's just, there's high variability, high sampling variability. There's a large standard deviation, there's large coefficient of variation, which it may not be, the estimates may not be reliable. So there is a community, the 2016 community survey, also used to get auxiliary variables or covariates. So I use the small area estimation technique to combine, to link these two data sources. So when it comes to the methodology, I'm going to spend a few minutes about this methodology. There is a direct estimator. The word direct estimator refers an estimator which can be obtained from the survey only, from the sample survey only. We call it direct estimator. So how do we calculate that direct estimators? We have these indicator variables. For example, YDJ. D refers district municipalities. J refers a person or an individual at the district municipality. So if individual J at the district municipality is unemployed, we just give 1, 0 otherwise. So the total unemployed people is just the product of that. WDJ is a design weight. just individual at the district municipality level. Similarly, ZDJ refers to the employment, that's the total employed, and in fact, we didn't use the inactive part in the study, so that's also another, the total inactive people. So this is how the unemployment rate calculated. It's the ratio of the YD, the total unemployed, divided by the sum of the total unemployed and total employed. The variance of this unemployment rate and the covariance between the total unemployed and total employed is just derived by these researchers, and it's published in 2013. So they use a Taylor series linear approximation technique to derive the variance and the covariance. So we use that relation. When it comes to the model-based, the spatio-temporal small area estimation technique, this technique, there is the word, I don't know, can I just press there? Yeah, there is a Fay-Heriot. Fay and Heriot, I just tried to mention a little bit earlier. These are the two scientists who proposed the linear, area-level linear mixed model for the first time in 1979. The purpose, objective of this model is to estimate income at the counties of the United States. Since then, this model has been used. So in 2007, researchers extended this model to accommodate spatial dimension. And 2013, again, a group of Spanish researchers extended this model to account the temporal variation. So this is spatio-temporal small area estimation, spatio-temporal mixed model. It's a mixed model which include that. So as you can see, there is a sampling model which is all about, deals about the sample part, and there is a linking model which links the sample data with the bigger administrative data source. And here, as you can see, there are U1D, U2D. So U1D is just, let me just say about U2DT, this is a time-specific random effects. You know, now, for example, in the quarter 4 of 2024, this quarter is not independent with the previous quarter. Whatever policy or whatever happened in the previous quarter impacts this quarter. And the next one, this quarter has also a kind of dependencies in the next quarter. So to accommodate that time variation, there's a time-specific random effect is added there. And the other part is the area-level random effect. This is added to accommodate the spatial variations. When you consider district municipalities, there is a movement of economic activities between neighboring district municipalities. So they are not independent. They share. If some policy or if something happen, economic activity happen in the neighboring district municipality, definitely it impacts the neighboring municipalities there. So there is a correlation. So that correlation is accommodated by using this, the area level random effects, using the spatial autoregressive model. So we're combining this all, this is the spatial temporal mixed model, all includes all the data from the consecutive surveys, the community survey, space, time, all are included in this. So this is a model-based estimate. We call it the empirical-based linear unbiased predictor. So let me just quickly go to the results section. This part, okay, did I just move? Yeah. This part is, it's a summary of, as you can see, the distribution of unemployment rate for youth between 15 to 24 in each quarter. And you can also see the trend. If you go from 2024 quarter 1 all the way down to 2022 quarter 1, look at the mean. It's more persistent. The unemployment rate is just more persistent in this age group. When it comes to, again, the gender, females and males, it's also there is a consistent high unemployment rate over all the 9 quarters. For males, same can be said. These tables, I just extracted the most vulnerable district municipalities in South Africa. You can say this is the hotspots. The hotspots. And where do they located? They are just, these are the district municipalities, these are provinces. This is just, for example, for females, which these are the district municipalities which contains above 60% unemployed women. And these are the district municipalities which contains 80% unemployed users. So it's just, we can say these are the hotspots. Again, I'm not going to talk a lot because of the interest of time. It's just like this is a plot which shows the variation within each province. Each province has district municipalities. What is the variation across the 9 quarters? So from this we can see, this is just particularly for the youth. Metro cities have been performing better than their neighboring non-metropolitan districts. Similarly for women, this is the same story, can be read from this area. This is another interesting plot. All the horizontal lines are the district municipalities, the 52 district municipalities, and the 6 demographic groups. The red one, that's the top one, is the one, the youth unemployment rate. It's consistently higher across all the district municipalities in all the 9 quarters. So mostly here women and youth adults from 25 to 34. They're just overlapping each other. And the next one is male, and the next one is to 35 to 49, and the least unemployed is obviously above 50 part. I'm not going to talk about the model validation because of the time. Yes, and also I have also maps here. Just for example, this is for the age groups across all the 9 quarters. All the darkers, this area shows, or this regions contains high unemployed users. And these areas, maybe this is Western Cape, this is Gauteng, consistently performing better than the other provinces or the other districts within those provinces. This is for females, and there's a similar message can be given. So there is age disparity here. What's the most important issue? There is age disparity. Youth, especially from 15 to 34, are the most vulnerable groups. And, okay, almost done. And gender disparity, there is also the gender disparity. Women found just a tough challenge in terms of getting jobs or employment than males. For example, if I take the 2024 quarter one, this is for women, the mean unemployment rate for women, this is for men. So as you can see, there is 5.83 percentage point difference. That's a huge difference, yeah. It's not a difference that we may ignore. And as summaries, I have few policy recommendations, but I don't think in the interest of time I can suggest. Just like government and private sector collaboration, there are experiences from EU and other countries, tax subsidies, educational and skill development initiatives can be considered, like for example, TVET in South Africa can be accommodated in private sectors and all other things, and comprehensive employment policies, affirmative actions. It's the one which was enacted in 1988. It has its own problem because of implementation issues, challenge, and again, existing inequalities, historical inequalities contribute that. Yeah, I think it's just, let me stop.
I'm going to make a comment, right? So I think from ERSA's side, and maybe I shouldn't speak for Fouché, I don't think you should make policy recommendations in this working paper. I think just present us with the data, the methodology, so that we understand what's going on. Leave the policy stuff for other things. This is about trying to understand what's going on in unemployment. So I think that would be much better. I really like this. I have one curiosity you probably can't spend a lot of time on, but the spatial weights, how quickly did they, what's the word, deteriorate, right? So, I mean, how many districts over were sort of used within the spatial weights?
It's a 52. The matrix is a 52 by 50.
I understand that, but
Yeah.
but did every single, like, does some district in KZN impact some district in the Western Cape? Are the weights still positive that far out?
Yes, the weights are considered. Yeah, some of the weights has to be one. That's the way that I considered, yeah. Thank you for the comment as well, yeah.
Just out of interest, because you've got the gender unemployment rates, are there like places in the country where the gender gap is biggest? It would be really interesting to see that.
Yes, yeah. Especially in those provinces like KZN and Northwest, Limpopo. These are just, in general, the provinces which contains the highest unemployed women, and the gap is bigger in those provinces, yeah.
So there's a big debate in South Africa between the broad and the narrow measure of unemployment, right?
Okay.
I'm wondering about your use, I presume, of the narrow measure of unemployment. The argument is that because of the lack of jobs, people are discouraged from looking for work, and therefore they are not defined as unemployed.
Mm-hmm.
If there were more jobs available, more people would enter the labor market, and your unemployment rate might actually go up because people were seeking employment. So would your technique could it be used to take a broader measure of unemployment, is one question. And then the other question is, can you comment on the issues of spatial distribution, and particularly are you saying that in remote rural areas, unemployment is generally higher, and in cities, I know you don't look at metros, but in some of these intermediate cities, what's the pattern across geography? That's a key question of this program of research. What's the spatial pattern to your results? I like your graphs going like this, but is there a consistent spatial relationship? Are some kinds of areas consistently showing higher unemployment than others?
Thank you very much for the presentation. Just curious, how much of work have you done in this? How much time did you get to this point? Are you working alone, and how far have you gone with it?
Sorry, can you repeat?
In terms of the work you've done, how long of work have you put into this? When did you start?
Oh,
Then what has gone into it? Is it a solo effort? Is it a joint effort? I can only see your name on it, so how much time have you put into this work? Thank you.
Thank you for the presentation. Fascinating. It feels a little bit like you've given us Quantec or IHS a secret sauce here, because I assume they take very similar sort of approaches. Just two questions. The one is that stats say that QLFS is statistically significant, supposedly at the metro level. We certainly use that. So have you tested your model against Stats SA's QLFS metro level statistics, and how well did it compare? So that's the one question. And the other question is, because this is modeled obviously based on some structural relationships in the community survey, I imagine that the specificity for shocks wouldn't be very good, because so let's say in the Cape Town context we had a water crisis which potentially could have peaked unemployment. How would this approach be able to accommodate temporal shocks? Thanks.
The one thing that I think would be quite useful would be to break up the districts between those which are traditional authority areas and those which are not. For instance, the Harvard studies show that significantly higher levels of unemployment in traditional authority areas. So that would be one thing that would be interesting to look at, but also have a policy implication. Maybe not a policy recommendation, but certainly have a policy implication. The second thing is that you could test your model against I work at the GCRO, so we've just released the quality of life survey. We have 2 districts in Gauteng. You'd be able to test your models against data that we have for those 2 districts. And I'm very happy to give you access to the data and discuss what the possibilities are of doing that. But overall, it's a really interesting paper. Thank you.
Thank you. Let me try to address some of them, Rekan, and some of the comments I will take and as a comment. Yeah. When it comes to inactive or those discouraged job seekers, I just use the studies questions. They consider the discouraged or inactive population separately. Like, so I only focused those which are defined by studies EU, like they usually go to the certain district municipality and ask individually, are you employed or unemployed? That's a kind of question. So, and I just only consider those those unemployed divided by the sum of employed and unemployed. That's the one which is incorporated in this model. But inactive one, I have seen there's another recent research which is done in UK. They also consider that the inactive proportion and the discouraged job seekers as separate in relation to unemployment. So maybe that's a future task, and thank you for that reminding me. I don't know if I answered that. And when it comes to cities and second cities, actually, I just consider in my understanding metros as cities and non-metros as just, that's how the district municipalities are named. So I saw from your presentation, Prof, in this morning, cities, metros, and second cities, and all other divisions. But that kind of divisions is not there in the studies data classification. So when I just get that, they only consider district municipalities with their names. That's how I got the referencing, yeah. And the other question, the time required, or I don't know if I hear your question properly. Yeah. It's just this is just a very tedious task. Like, I have to consider. First, I want to point out that in June 28th, there was a workshop. My initial consideration was I consider metro and non-metro. I just merged non-metro municipalities as one and metros are separate. So there are 9 metros in South Africa and 8 non-metros, so 17. So I was given a comment to consider, please go a little bit down. So that was another challenging task. So I have to go and clean all the 9 quarters data, even the community survey. So it just, yeah, it has been a nightmare, but I think I managed to do that, yeah. But it's just, the result is improved, definitely. I really appreciate for those suggestions, and that workshop, yeah, plays a vital role. And the KLF results at the metro level, I didn't compare that because I only just, the study CA only calculated the metro results from the QLFS only. What I have done here, in my opinion, my result can be better because I use various information. Like this smaller estimation, they call it borrowed information, borrowed strengths. We borrow information from other bigger administrative sources to improve the accuracy and the precision of estimates. So maybe I will go and check if there is a variation between my metro level estimates and the one which is presented by studies here. I'll just check that. Yeah. And the other one. Yeah, the shocks, yeah. I'm sorry to say this, there is no way like that I can accommodate that shocks because these are like a kind of existing methodology. You know, this model is a very complicated model. Like if I see how the mean square errors, all the empirical base linear unbiased predictors are, because it's combining data from different sources. We're not using one data through time and model that. So that combination, that linking data from different sources makes the modeling aspect more complicated. So there is no way to accommodate that. So maybe that's another way to think about in the future. But in this small area estimation context, there is no model which exists to accommodate that shock. Yeah. But that's a very interesting point. Yeah. Okay, it's a pleasure. Very good.